Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Iman Izzati binti Jasman. My matric number is AA190971. I am 1DAK student. Okay, it is clear that Madam Hana has given us the task of completing case study 3 and 4. My group has 5 members including me. Our group name is Byzantine. Okay, I would like to introduce you who my group members who have done a great job and have a great commitment to completing the task. Okay, first.
Assalamualaikum. My name is Muhammad Aklam Rosli. Number matrix AA192055. So, in this part, I will explain about result and discussion.
Okay, second.
Assalamualaikum. My name is Irina Fatihah binti Zulhelmi, student of 1DAK, matrix number AA190550. Today I'm going to discuss about case study 4.
Third.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Naini Ajimini bin Soekarno, matric number AA190160, and today I'm gonna present about the case study 3 and how to solve it.
And fourth.
Good morning to Madam Nohana and all my friends. My name is Lim Hui An and you can call me Lim. In today's presentation, I will present about 1.1 Villa table for case study 3 and case study 4. Thank you.
Okay, next I will tell you a little bit of our discussion journey for this assignment. Alhamdulillah, we were able to talk even though we could not meet face to face. We conduct online meetings through mediums such as WhatsApp and Telegram, so that no one is missing information about this assignment. At first meeting on Saturday, 18 April 2020, from 10 AM to 11 AM, all the members of my group gave a good cooperation, and during the meetings, we do some activities such as brainstorming, analyzing the key points for each case study, and distribute the task among members. Okay, for the next meeting on Saturday, 25 April 2020, from 9 AM to 11 AM, we also use the same mediums like at first meeting. We discuss the answer for each case study, analyze data for each case study, and record the video presentation. And for the last meeting on Saturday, 2 May 2020, from 10 AM to 11 AM, we edit the video, arrange the data in the report, and do a final analysis for the report. Okay, next I will explain you about introduction of case study. Calculus is the study of how things can change. It was developed to understand the quantities that change continuously. Calculus enables people to construct simple quantitative models of change and to deduct the consequences. One of the most common application applied to calculus is the field of optimization. Through the concept of optimization, we can find the optimal result, such as maximum or minimum, by determining the value of controllable quantities. Okay, for a daily life example, the concept can be used when an employer is interested in determining the number of employees in factory that will maximize the profit, or numbers of employees that will maximize the cost. To solve an optimization problem, it is important to understand the concept of differentiation. The derivative of the function is the instantaneous rate of change of y with respect of x. It is the slope gradient of the tangent line to graph function. process of getting the derivative is called the differential by using the first principle. Okay, in case study 3 and 4, they are both optimization problem that can be solved by applying differentiation concept. Thus, it is important to know the basic principle for this topic. Okay, look at this side about differentiation properties, and you can look all the properties. As we know that the most important in differential calculus is optimization problem. Okay, at this side you can see some information about maximum and minimum values. Okay, once the critical point obtained, it is easier to find the extreme values of the function. Okay, first we must verify the function is continuous or not. Second, we must find the critical points. If the domain is given, use only the critical point that fall inside the domain. Step 3, substitute the critical point and endpoint interval if given into the original equation. And the last step you must do is identify the extreme values, the largest function as maximum and the smallest function as minimum. Okay, next presenter after me is Lim.
I'm Lim, and now I'll continue the presentation today with 1.1 pillar table for case study 3 and case study 4. So the pillar table consists of 4 parts. So the first is the fact, second is the basic idea used to solve this question, third will be the learning issue focused in this question, and the fourth will be the action plan taken to solve this question. So the question said that as robbery and kidnap cases they become frequent nowadays, Amina decided to do the home fencing. She decided to fence her home area, which is a rectangular plot using the barbed wire. So 2 of these sides will use the heavy duty fencing, which costs 13 ringgit per meter, and the remaining 2 sides will use the standard fencing, which costs 15 ringgit per meter. This question asks for the dimension of the maximum area. So we know that this question will be an optimization question. So the first step to solve this question is that we draw out a rectangular plot and label all the variables provided in the question. So these 2 sides will use the heavy duty fencing, which costs 30 ringgit per meter. So we label it as 30x. So these 2 remaining 2 sides will use the standard fencing, which costs 15 ringgit per meter. So we label it as 15y. So the second step, we can write down all the formula which are related with the diagram. So this is a rectangular, so the common formula we use is perimeter and area. The next step, we have to determine the constraint equation and the optimization equation. So the optimization equation is about the quantity that we have to optimize in this question. The constraint equation is about the value which the question will constrain about. And the last, we will apply the differentiation rule to find the dimension of the rectangular plot. We will differentiate the optimization equation in order to find the dimension of this rectangular. So there are a few learning issues focused in this question. So the first, how we are going to form a constraint equation and an optimization equation. What is an optimization equation and what is a constraint equation? The second learning issue is about how we are going to determine the dimension of the maximum area. Since this is an optimization question, so what is the common step we have to use to solve this question? And the third, how we are going to apply the differentiation rule, how we are going to differentiate the optimization equation. There are also a few action plans need to take to solve this question. So first, we have to identify the step in solving optimization problem. So also we have to find some of the information and the similar example from the website. We have also watched some of the tutorial video in the YouTube so that we know how to solve an optimization question. So now I'll continue with the pillar table for case study 4. In this question, Mr. Ali wants to build a conic tank with the base radius r. The capacity of the tank should be 650 meter cube. That means that the volume of the cone is 650 meter cube. The height of the tank must lie between 10 and 11 meter. That means that the height of the cone can be bigger or equal to 10, or it can be smaller than 11 or equal than 11. So the first step to solve this question is similar with the case study 3. So first, we draw a conic cone and label with all the variables. So we label this with r, radius, height, h, and this one will be the length height s. After we draw and label with all the variables, we found that this one is a triangle. When this is a triangle, we can apply Pythagoras theorem. We can let r as the subject, The next step is that we apply the differentiation rule. We differentiate the optimization equation in order to get the critical value. So after we get the critical value, we have to sub in the endpoint interval given by the question back into the original equation. But we have to take note that we can only take the height of the cone that is lie between this domain range only. So if the value fall outside this domain range, so that value will not consider as the answer. Then with all the value found, we can sub in the value into the area formula. So the area of a cone is A equal to pi rs. So the last step, we have to choose the minimum area value in order to minimize the material use. We have to choose the minimum area values. That means that the smallest area value. So with the found area value, we can determine the dimension of this cone. So the dimension of this cone is radius r, height s, and also length height s. So there are a few learning issues focused in this question. First is how we are going to apply Pythagoras theorem. What is the Pythagoras theorem state about? So second, how we are going to apply differentiation rule. How we can differentiate the optimization equation. And the third, how we are going to find the dimension to minimize the material use. What is the common state used in the optimization problem to find the dimension? There are a few action plans that should be taken in this question. First, we refer back to the notes given by the madam. And also, we found some of the information and similar example from the website. And also, we watched the video from the YouTube so that we can understand better in this question. This is all from me. Thank you. Now, I'll pass to my teammate, Naim, to explain the solution for the case.
Assalamualaikum. Here I'm gonna present about the case study 3, home fencing. First, we need to take a look at the question so that we can understand what we want and we can take out all the information that it needs in our calculation next. So here, as you can see, is the question for the case study 3, home fencing. So first, I'm gonna read the question first. The robbery and the kidnap case that becomes frequent nowadays make Aminah plan to take pre-action prevention. She decides to move the first step by fencing her home area, which is rectangular plot, by using a barbed wire. She intends to use two different types of fence. Two opposite sides will use heavy duty fencing, cost 30 ringgit per meter, while the remaining two sides will use the standard fencing, cost 15 ringgit per meter. Here we will ask to help Aminah to identify the dimension of the maximum area that can be fenced in a cost less than Rm 30,000. The information you can get from the question is that the heavy duty fence costs about 30 ringgit per meter, the standard fence is 15 ringgit per meter, and the cost of the fence must not exceed Rm 30,000 ringgit. And we will ask to find the dimension, which is width times by the length of the maximum area that can be fenced within that cost. For this case study, I'm gonna use chapter 4, the application of the differentiation as the guidance to help me calculate to help me solve the problem. So first for this case, from the question we get the information is that the heavy duty fence costs about 30 ringgit per meter, and the standard fence costs about 50 ringgit per meter. So we will ask to find the dimension of the area that can be fenced and must not exceed 30,000. So it's the picture of the visual of the area of the fence. So both of this side is 50. So since we don't know how long is the distance from the one point to the point, we will make it into s, 50s and 50s, and both of this side is 30x is because it was 30 ringgit per meter, since we don't know how many meters it is. So first we need to find the perimeter of the area. We need to find the perimeter of the area, which is B equal 2 of 30x plus 15y. We need to use different numbers. Then we need to solve it. To make it easy for us, we will factorize it. So it will be 30 x plus y, then y equal p over 30 minus by 2x. Here is our first step. The second step is we need to find the area of the fencing. So area A equal 30x times by 50y, which is width minus times by length. That is the formula of the area. A is 450 xy and less than 30. So we will use the equation we get here, and we will the amount of the y, and we will replace it into this equation. And we will get 450 xp over 30 minus 900x cubic. The step 3 is here. For the step 3 we will use the formula in the chapter 4, the application of the differentiation, which is dA or dx equal 50p minus 1800x. Here we will differentiate the equation. So here we got the amount of the x, 50p over 1800 equal x. Then for the step 4, we will calculate for the amount of y. So y equal 50xp minus 900x. Y equal 50 over 120 minus 100 P equal 120 cubic meter. Y equal 1.8 P. So here we got the amount for the y. So 1 over 16p metric. So after we get the amount for both of the unknown, we can move to the step 5, which is we will use the original equation, which is the equation of the area. So A equal 30x times by 50y. Here A is 30,000 because it was the amount we need to fence the area. Here we will replace x with the amount we get from the previous calculation. Times by amount of y we get, which is b squared plus 6. then we will need to solve this equation. So here is the amount of the P or the perimeter we get 50.39 meter. After we got the amount of the perimeter, for the step 6, we need to find the area of it. Since it's S over 120, we will need to find the amount of the S using the answer we got, using the amount of the P we got before. So 50.397 over 120, get 0.4997 meter. It's the amount of S. After we got the amount of S, we need to find the amount of the Y. So Y equal 1 over CC. We will replace the amount of P with the answer we got before, 2.7. Here we got 158.7 watt amount of Y. After we got the amount of the both, after we know the amount of the unknown, both of the unknown, S equals 0.4197 and Y equal 158.741 meter. We can find the true area of the maximum dimension we need to build the fence. And the maximum cost we need to know to build the fence. So 30 0.41997 times by 15, 58.741. Got and the total cost is 29,999.91 ringgit. So that the cost to build the fence, the cost we need to build the fence on a house is less than 30,000. So as you can see, that is how the calculation we need to do to solve the case study for the we need to solve for the case study 3. So for the second case study 4, I will give to Irdina to solve it.
Case study 4. Mr. Ali wants to build conic tent with base radius r. The capacity of the interior of the tent is 650 meter cube. Because of the certain reason, the height h of the tent must lie between 10 and 11 meters. Find the measurements of the tent so that as much as possible of the material canvas used can be saved. Use area A equals to pi rs. The first step is draw all the lines for all dimensions for this cone, and then we will get this right angle triangle, and we can turn this right angle triangle into a Pythagoras theorem, and we will get a square equals to h square plus r square. And then use the formula volume of a cone, which is V equals to 1 over 3 pi r square h, and then substitute the r square for s square plus h square. Simplify this, and then we will get V equals to 1 over 3 pi s square h minus 1 over 3 pi h cube. And then differentiate this equation into dV over dh, and then we will get 1 over 3 pi s square minus pi h square. And then dV over dh equals to 0, and try to solve this, and then we get h equals to root 1 over 3s. This value is the critical point. And then substitute the h value into the original equation, and it is very hard to calculate with this root 3. So we're gonna let the root 3 into x, try to solve the equation, and then we will get the value of s. Use EQN, and then we will get s equal to 2.590 meter and s equal to negative 1.295 meter. This value is excluded because it cannot be negative. And then use the domain, which is h equal to 10, and substitute that domain into the original equation, try to solve it, and we will get s equals to 12.731 meter. And again, use the same thing with the domain h equal to 11, substitute it into the original equation, and try to solve it until we will get the value of s is 13.320 meter. Next, play out all of the value of h and s that we get, and try to eliminate any value that is unsuitable. So this value of h, we need to exclude it because it falls outside of the domain. So when this is eliminated, this s will be excluded too. And that leaves us with 2 value of h and 2 value of s. We still need to do further calculation because we need to know the minimum value of the area canvas used. So continue the calculation. Use the area given, which is A equals to pi rs, and substitute the r with this theorem Pythagoras, and then try to solve this equation until we get the value of A, which is 315.125 meter square. And then do the same thing with the formula given, but this time we substitute the h with 11, the domain 11, and then we'll get the area 314.326 meter cube. So we'll take this value because this value is smaller. And then use the previous value of A to get the value of R, and then we get the value of R is 7.511 meter. And then list out all of the final answer, all of the dimensions that we get related to the minimum area of the canvas, which is R equals to 7.511 meter, H height equal to 11 meter, S slant height equals to 13.320 meter, A area equals to 314.3253 G26 meter square, and then the volume V equals to 650 meter cube. So that's all. That is the final answer for case study 4.
So, in this part, I will explain about result and discussion. This part is divided into 3 parts, which part 1 is about checking the information from the question. Part 2 is about understanding what the question wants, and part 3 is about solving the question. So let's get into understanding the question, part 1. So in question number 3, the information given is Aminah, who wants to build a rectangular fences that consists of 2 elements. The first 2 sides consist of heavy duty fencing that will cost Rm 30 ringgit per meter, and the other 2 sides will build up for standard fencing, which costs Rm 50 ringgit per meter. Question number 4 is about Mr. Ali, who wants to build a conic tent with base radius label SR. The capacity can be fulfilled by 650 meter cube, and the height must be between 2 to 11 meters. Next, in order to understand the question, for question number 3, it wants us to identify the dimension for maximum area in a cost Rm 30,000 ringgit. Meanwhile, for the question number 4, what we need to do is we need to find the measurement for the tent so that the canvas can be used minimum quantity using formula A equal to pi RS. So to solve question number 3, first we need to calculate the perimeter of the fence. The answer of the perimeter will be P equal to 30 bracket 2x plus y bracket. After that, we will calculate the area, which is the length multiple the width, and get 450 xy. The answer that I obtained will insert into the formula, which is A equal to 450x bracket P over 30 minus 2x, which the value of the y that had been derived from the perimeter calculation. The answer from the formula that we get will be A equal to 15xp minus 900x squared. Then after that, we differentiate it to become dA over dx equal to 15p minus 1800x. The differentiation value will be derived into p over 120 equal to x, then substitute into y equal to 15xp minus 900x squared. And the answer that we'll get is y equal to 1 over 16p squared. The value x equal to p over 120 and y equal to 1 over 16p squared, then will be substitute into a equal to 30x times 15y to get the answer 162,000 over 15 equal to P3. The P3 value will end up as P equal to 50.397 meter. After obtaining the P value, we now can solve the equation x equal to P over 120 and y equal to 1 over 16p squared. And the answer will be x equal to 0.5 41997 meter, y equal to 158.741 meter respectively. So to obtain the price value, we will using a equal to 30x times 15y. The price value that we get is RM to 29,999.91. So to solve question number 4, first we need to list the equation, which is s square equal to h square plus r square. Then the formula will be derived into r square equal to s square minus h square. The r square equation that we derived just now will be inserted into the cone formula, that will be v equal to 1 over 3 pi bracket s square minus h square bracket h, and the answer that we'll get is v equal to 1 over 3 pi s square h minus 1 over 3 pi h cube. The equation obtained then will give us the critical point, which is h equal to set 1 over 3s from differentiation of v equal to 1 over 3 pi s square h minus 1 over 3 pi h cube. V equal 1 over 3 pi bracket s square minus h square bracket h equation will be 620.0704 equal to s cube over c set 3 minus s cube over bracket set 3 bracket power 3. From the substitution, we get h equal to 1 set 1 over 3s into the equation. To simpler, 620.704 equal to s3 s cube over c set 3 minus s cube over bracket set 3 bracket cube equation. The set 3 will become into x, then will be converted into the equation, which lead to 630.704 equal to s cube over x minus s cube over x cube, and the answer from the conversation will be s cube minus s minus 14.775 equal to 0. S value will be 2.590 and negative 1.295, but because of the negative value, the negative 1.295 will be excluded. The original equation, which is v equal to 1 over 3 pi bracket s square minus h square bracket h, will be solved with the h value equal to 10, and from the substitution we can get s value, which is s equal to 12.731 meter. Next, the other h value, which is 11, will again substitute into the original equation, which is v equal to 1 over 3 pi bracket s square minus h square bracket h, and the answer that we will get from the substitution is s equal to 13.320. However, the value of h equal to 1.495 will be excluded from the substitution because the interval given is between 10 and 11. Therefore, the value of s that we obtain, which is 12.731 and 13.320, will be substituted into equation a equal to pi rs respectively. That will lead to obtain two answers for equation A, which is 315.125 meter cube and 314.326 meter cube. Since the value of A equal to 314.326 meter cube is smaller than A equal to 315.125 meter cube, we will take A equal to 314.326 meter cube. So, after the value A is determined, we now can find the R from the derivation of equation of A equal to pi rs. But the equation now will be 314.326 meter cube equal to pi r times 13.320, and the R value that we will get is 7.511 meter. Thank you.